and welcome to video number 4 of our GUNPLA series, where I'm going to kind of continue doing this hard surface model for my robot, which is, where are you? Show. Okay, first cancel, show. There we go, for this guy right here. So in last episode, or I don't know, last video, we created this backpack with a bunch of boosters, but the thing is that right now it's completely disconnected from the robot itself. As you can see, I can just freely move it away. And I need some sort of a mechanism on how to actually connect this backpack to the guy here, right? To the robot here. And I'm thinking about it, you know, like how to do it. One way would be to create these kind of straps of plastic that would be kind of wrapping around here and then going back and here as well. So these kind of two clips of plastic, but that is, first of all, that really relies on tolerances being tight, and as you can see here, the tolerances are not tight, and also it's a little bit conventional. So I'm thinking of continuing on with this kind of tube aesthetic and creating these kind of sticking out tubes that would like 4 spikes that are sticking out, 2 in the top part and 2 here in the back part, and then somehow figuring out how to connect it all. We'll see. But for now, let me hide the robot. For now, I want to fix this, because this I don't like how this portion looks like. Everything else here is like, I thought about it, and everything else here seems to be kind of okay. Except this this tube here. So to fix it, I will just simply duplicate edge. I'll duplicate this edge, and I will, let's go for extrude. I will extrude curve, and I'll just extrude this edge until here, right? And then so now I have a basically just a cylinder there, right? And then what do? I kind of want to keep this portion, this one I like, so I'll extract surface, and I'll just extract this ring here, which means that this whole part gets disconnected from the initial poly surface, so I can just join them up. And also, let me hide this for a bit. And also I want that part right there. So I'll also use extract surface, extract that one, which means that all of the of these 1, 2, 3, 4 other surfaces get disconnected from the initial poly surface, and I just join them up into one dimple. So now I have this shape that I don't really need. I have this one, and I have this one. Okay, that's good. Should we keep? Yeah, I will also extract surface, and I will just extract these two guys here. So now let's get rid of this. I just select it and delete it, and as you can see, some parts were left here. So now, first thing that I want to do is I want to mirror this, to the other side, to here, I think. Or should we cut it in a... Yeah, maybe we can cut it rather than mirror it. Yeah, we'll see. So for now, I'm just going to leave it as it is, and I'm just going to join it. Without joining this or this, without joining these two, I'm just joining this one, and yeah, we will just cap to close it off. So now, if I show selected, and actually let me get rid of these tubes here. Oh, those are in the same layer, super. you can see there is an intersection going on because we need this portion to be flush cut. We need it to be cut flush. And to do that, I already have a curve here, like that. So what I'm going to do is, holding down the Shift key with the gumball, I'll increase the size of the curve to something like this, maybe smaller, something like that. So when you hold down the Shift key, it scales everything up automatically. So we have it like that, maybe even smaller. Yeah, looks about right. And I will extrude this curve so that it extrudes perpendicular in a perpendicular direction, like so. And maybe we will want this to be at a cool angle, so I will just duplicate edge to get the other, we have the closer ring here, duplicate edge. We had this edge as an original, and now I've just extruded and duplicated edge to get this curve right here. So let me delete the ring. And if I were to increase, holding down the Shift key again, increase the size of this guy here, and then loft them, like that, then select the ring and cap it, we will have a cutter that should work quite well. Let's try. So I will select this guy, Boolean difference with this one. Ah, looks about right. Okay, good. So we have that going on. Let me hide the sphere for a bit. And let's see how we can connect these back to the shape, because right now they're disconnected. So this one is going to be easy. I'll just use trim and just trim away the we need to use the shaded tool. No. Okay, so I will not do the trim. Instead, let me hide it again. Let's go back to shaded view. I will duplicate edge, like that. For now, I'll just hide it for a bit. And I'll use this edge to trim. Now this should be fine. Like that. And I believe I will do the same thing with this one. I could use Boolean difference, but might as well do the same method. So duplicate edge, hide this one, select the edge, trim. By the way, when Boolean operations don't work, you can always try this method, and this sometimes works well, not sometimes, most of the time it works much better. Okay, so now I have this shape here and these two shapes, and I believe if I join them and type in what, valid surface, closed, super, it's closed, solid polysurface, so that's what we want. Okay, so I just cleaned it up a little bit, nothing too fancy, just wanted to kind of have it going in a nice way. Let's show, and I will just mirror it to the other side to just see how it looks like. Yeah, a bit better. Those fins where I wasn't a fan, and now we can see these rings here. It's nicer. Okay, so we have that going on. Now I believe, what do we do? Now I believe it's time to actually connect it to the, well, not connect it, but create some sort of bracing system for this model. So I will say, shall we work with lines? Yeah, let's work with lines. So I will create a straight line. Should we do it in top view? Yeah, perhaps let's do it in top view. Shade it. I will create a straight line like that. The distance, the length of it doesn't matter. And I will actually create a new layer and call it helper and make it blue, hello, blue. There we go. Change object layer, and also I'll make helper the active layer. Okay, so we have that line going on here, and basically I want the bracing to go above the shoulder plates, not shoulder plates, but I don't know what this is called, the collarbone, above the collarbone, and below the armpits, or below the, not the armpits, but how are these called? Ribs, the rib cage below here, right? So before I will do the one with the collarbone, the top one. So in the top view, let's see. Well, it needs to be definitely rotated. A little bit like that, I believe. Seems to be good. And then in front view, let's say, I have no idea what kind of angle this is. So hard to tell. So let's do it in perspective instead. Yeah, definitely. Or maybe, sorry, I'm blabbing a bit. I'm just trying to figure out the angle of the line. Maybe just something slightly like that. That should work, right? Okay. Then I will push it in. And this is like looking straight at the line. This is the angle that we get. Maybe it can go a bit more like so. Yeah, that seems okay. Okay, so we have one line done. And I will just increase its size, holding down the shift key again and dragging on the gumball to just have an idea of what's going on. And now for the next one, I believe what we can do is we can just, holding down the Alt key, copy it down, just like that. And now find a good position for it. So looking at the actual model, this is a single surface, which means we can follow it, which means I will probably do something like, let's go to top view. I'll probably do something like this in the top view, so just slightly rotating it. And now this will need to rotate quite a bit. Can we actually see it in the, oh yeah, we can. So I want these directions to follow, and they seem to do. So that's good. That's good. Not really happy about this angle here. Perhaps we should keep it. Perhaps we should keep it horizontal. Let's see what's. No, actually, yeah, that's fine. Yeah, that seems to be okay. Okay, and can this one move a little bit out and a little bit higher? Super. Okay, so we have these two guidelines here, and I will not be working further with them, and I will just scale them up individually to be longer, so that we don't need to deal with the, if there's not enough length in the future. And I'll just use pipe on them, and we need to decide what kind of thickness we use. I believe like 2 millimeter radius should be okay, like 4 millimeter diameter. It's a little bit intersecty. Let's try 1.6. Yeah, 1.6 seems to do the trick, so I'll do the same thing here. So it's actually not 1.6, it's 3.2, because it's the diameter is 3.2, and if I were to measure the thicknesses of the plates here, that's 1.6. Let's see, 1.5, 3.2. It's a little bit thin, but I think we can manage. Okay, so 3.2 is here. Let me quickly mirror it to the other side just to see how it all looks like. Doesn't seem too bad. We will be fixing, all of the intersecting issues and so on. And now the thing that I'm going to do is I will lock these blue ones together with the robot, and I will select everything else, and I will position it in a way just slightly lower. I just want to position it so that these guys fit better, because here I can see there's going to be some intersections and so on, and this is the last time when I actually work with the composition of it. So this can stick out and do that, and this one. Actually, this is pretty good. Yeah, okay. I just slightly moved it down, but nothing else. All right, so we have these pipes here going on. That's super. And we have the robot. Let me actually hide it for now. And now we need to connect these pipes with the shape here. So actually we already have like a connection area here, which we can use. That's superb. And we will need to figure something out here. I don't know. We'll do something with it. Yeah, we'll figure it out. Okay. So for now, let's solve the bottom one. So for this one, I believe we can duplicate edge. We can get this circle in the base of the hole, and I will offset it inwards by 0.1, so that there's no so that it can fit. And I will extrude curve, and I will actually, this is 4 millimeters, I will extrude it slightly out, so let's say 5.5 millimeters, 5.5, something like that. And then I will duplicate edge, get this edge, offset, and how thick do we want this boy to be? Let's say 3 millimeters, 3 extra millimeters here. Should it be thicker? Nah, I think that's fine. Between these two curves, the inner one and the outer one, I'll create a planar surface. And for this curve, I will just extrude it. Extrude curve. And extrude it, let's say for 13, I don't know, 13 millimeters. Something like that. Okay, so now we have an intersection going on, which we will need to fix. But at least now we have some form of geometry that can hold this new pipe that we've done. I will just cap it like so. Okay, so now let's think about this. This tube needs to go in. Okay, I will use extract surface on this base surface here. Or actually, can I not do that? Duplicate edge rather. Yeah, I will use duplicate edge here. And then let me offset the edge outwards by 1.6 millimeters. Is that really 1.6? Holy crap, that's thick. Distance. Yeah, that's 1.6. Okay, let's try offset SR, rather just offset 1.2. Yeah, we can deal with 1.2. Okay, so we have this guy going on here. And let's move everything to somewhat of a correct position. So I'll take these two curves and move them. Let me turn off center snapping for a bit. So I'll move them from here to somewhere. Right now I'm just visually kind of checking it out. Somewhere here maybe. Something like that. That should be fine. And basically this guy is going to be extrude SRF, no, sorry, extrude CRV, extrude curve, and this is just going to be an intersection here, like that. So that's easy, and let me cap it, and actually already use Boolean union to kind of join it in. And then this inner curve is going to be used as a hole for this tube. So let's see how we can fix it. Let me turn off the tubes, and I have this inner hole here, or rather inner circle here. First of all, I need it a little bit wider because the tube is, it can't be the same width as the tube because it will not fit because of how 3D printers work. So I will just offset surface, or keep saying offset surface. I'll just offset this circle outwards by 0.1, or either let's have a snug fit, so 0.05 millimeters, like that, and just extrude CRV and just extrude it inwards. I think something like 7.5. Let's do 10. No, 10 is also bad. Let's do 8. Sure. 8 millimeters should be good enough for a fit. And then I'll just cap it. So now I can take my original cylinder and Boolean difference out this inner cylinder here to make a hole. Let me clean everything up a bit. So I'll cell CRV, select curves, and I'll just hit delete to make sure that there are no curves here. Okay, so we have this going on, and I have my helper here. Oh yeah, and of course, this cylinder needs some trimming, but the thing is that it's the only place where it's kind of, let me turn on wireframe. The only place where it's hitting the red cylinder here, the blue cylinder where it's hitting the red cylinder here, is at the back of the hole and also here. So I can do Boolean difference, subtract from this guy, enter, subtract with, and I'll choose delete input to be no. I'll subtract with this cylinder here. And you can see now this blue cylinder got disconnected into two parts, one that fits perfectly inside of the hole and the other is, the unnecessary end of it. Okay, so we have this going on. That's great. Shall we do some, I'll just quickly do some chamfering, but nothing too much. So for this to fit better, I will chamfer edge. Oh, that's a 1 millimeter chamfer. I'll chamfer edge by 0.3 millimeters here. so that it's easier to fit in the cylinder. And actually, let me do it like so, 0.3 there. But if I chamfer that part, that means that I definitely need to chamfer the cylinder, like the edge of the cylinder as well. So we will do that right now. Chamfer edge, so that everything fits perfectly. So now it's chamfered. Okay, good. Back to here. What else? I believe this is a bit meh. So I will chamfer edge, and I'll actually chamfer with 1 millimeter here to have something like this going on. Should this be... Maybe we can use fillet edge on this one. So fillet edge will, rather than making a straight chamfer, rather than making a straight chamfer, it's going to round off the connection. So fillet edge, radius 1 millimeter, sure. Let's see how it works with this. Let me put on an EMAP on it just to see better. Yeah, that's not bad. Yeah, that's fine. Okay, EMAP close. Okay, so we have that going on, and what else? I will deal with this part later. We'll make it pretty. Maybe we need to fix this. Okay, so chamfer edge. Let's go for 0.5, like half a millimeter for this one. Looks okay. And this one as well. Yeah, okay. So we'll have it like that. And this one travels to our model layer because it's kind of finished. We don't need that part, and we can just delete that. We can just take these two guys and the curve and just mirror them around 0 point, holding down the shift key to the other side, just like that. Okay, so we have the bottom part done. Now it's time for the top part. And for the top part, let's think about this. Maybe for the top part, should we still do a cylinder, or can it be like a sphere? A sphere would look weird, right? Yeah, let's just do a cylinder. Okay, so I will, let me delete that. Don't want that. And let me actually hide that. I only care about the curve now. First of all, I will select point here. Is there like a tangent snap? No, there's not, of course not. So that will not work, but can we create a point in the middle of this sphere? So if I turn on center, yeah, super, it snaps right to the center. If I hide the sphere now, there's the midpoint, which means I can start drawing, or rather, how do we do this? Show selected, sphere, let's go for wireframe view, start drawing from the midpoint, shade it, and just snap to somewhere on this, whatchamacallit, on this line. And for that, I will perhaps work in the top view so that the directions kind of align between these cylinders. Or do we, maybe we want them to be like that? Nah, maybe we want them to be like that though. How is the model looking like? So the head might be in the way. Let's see, the head is gonna be, not the head, but those bunny ears might be in the way. No, they won't, which means I can snap to somewhere here. Okay, let's do it. So I just snap to that point right there. Let me turn off the robot for a bit. That's the curve that I have, and I can actually split it with the sphere here, so that now I have two curves. I will delete the inner one, and I have this small curve here that I can now scale up, holding down the Shift key, like this. Do we scale it up more? We'll see. But I will definitely pipe it. Pipe. Ooh, much thicker. Pipe 3.2 millimeters. That's a bit better, but we can go even thicker. Pipe 4 millimeters. Yeah, that's good. Kind of good. But I want this to be a little bit out more. So I will scale 1D and scale from this point to this point. I will scale it out, maybe something like so. I'm just like the reason why I'm scaling it is not because of something functional. I'm just looking at the composition and how, you know, how balanced the composition is. So this seems okay. Back to our, well, actually let me cut away the unnecessary part here. So Boolean difference with this one, and select that one, hit delete. So now I have, you know, a perfectly fitting cylinder thingy. Okay. And now I kind of want to do the same thing as we did here. So where's our show selected? There's our champion here. Duplicate edge. We get that curve. Let's move that curve. Come on, from here to here. Oh, I messed up. Didn't move it in the correct direction. So, oops, move it again. There we go. Here. Okay, that's good. Oh, that's a little bit too far. So I will move it back. From here to maybe something like this. Yeah, this should be okay. So we have this curve. So first thing is we offset this curve out by 0.05 millimeters, right? That's going to be the hole. And the next one, we offset it again by 1.2 millimeters. That's going to be the receiving cylinder itself. I'll extrude the curve and I'll just choose solid yes, make sure that it intersects with the initial cylinder, use Boolean, not Boolean difference, Boolean union on both of them. So now they're one closed poly surface. Take the small one, extrude curve. I used 8 millimeters, so I'll use it again. That's the wrong direction, so I'll make sure that the extrusion direction is correct. Click to accept, and now just Boolean difference, Boolean out this cylinder here. So now we have an opening in which our tube fits. Well, not really, because it still needs to be trimmed, so I will do Boolean difference on it with this one, and get rid of the back, the leftover cylinder in the back of the form. Okay, so now we need to work with this one. I will select it and isolate, Now let's see. So first things first, fillet edge. We want this to be consistent with the bottom one, so in radius 1 millimeter. Oh, there are two edges here, this one and this one. Ooh, and it breaks. Shit. Or wait, maybe it won't. Rebuild. No. Crap. Extract or explode. Explode. Join. Wireframe. Shaded. Nah. Extract surface. So this surface just broke. Oh, something. Oh, I forgot to select this edge here to fillet. So that's my bad. Actually, can we align seam or is it just seam? Surface seam. Select the surface for seam adjustment. Okay, I can't because this is a trimmed poly surface thing, so it doesn't matter. Fillet the edge. So I missed this guy, so that's why it broke. Now it should be fine. Yes, it is. And then chamfer edge 0.5. That means it's the outer one here. And then chamfer edge again with 0.3 for the inner ones. Like that. Looks good. Show selected. Let's see the cylinder thingy. Isolate it. Chamfer edge. And fix that edge there so that it fits perfectly. Show selected again. This one. Clipping plane just to double check. Where are we? There we go. That's good. Yep. All of that seems to be fitting quite well. Actually, can we show? Let's just see the whole thing. Are there any problematic areas? So everything here up until now is fitting nicely. I'll just move the clipping plane here. Fitting nicely, that's good. No intersections there. This just fits. Fits. And now let's, yeah, that's good, and that is also good. Super. Okay. So we have this done as well. This is kind of a boring connection here. Can I chamfer edge? Can I use like 1 millimeter to chamfer this edge like that? 1 millimeter is too much. 0.5 instead. Yeah, I mean, why not? Looks fine. So we'll do that. Can it connect though? Let's think. I'm just thinking. How does it treat the surface? Or rather, we will do that during the detailing phase. That's fine as well. So we'll just select the curve, select this one, mirror, 0, mirror it to the other side, and we have something like this going on, which already is kind of cool. I enjoy it. So let me select these guys, and these are not helpers, or rather the curves are helpers, but these are cylinders, and these are part of the model. I will figure out if I want to Boolean union them to the model, or if I want to do something else with them later. So let's see how they fit. So basically this whole thing is just going to kind of be locked in place. It's going to be loose, it's going to be wobbly, but I think that's fine. I do want to fix this portion here. I don't really like how it looks like. So let me get rid of that. Like this, and we will be fixing just half of it, of course. And let's start with, actually we don't need a model, we just need these. Let's start with the length. So I will not scale. Instead I will use solid points on and just grab that single control point there and move it. Let me turn off quad snapping because it's getting in the way. Move it back until somewhere here, maybe even more. Something like that. Okay. And now, same thing for this guy. Solid points on. That control point there, move it back. Somewhere there. Yeah, that's a bit better. And now let's extract surface, extract these two, get rid of them, hitting delete key, duplicate dupe border. Let's get the two curves here, and let's work with the bottom one first. So I will offset it by 1.2, I guess is fine. So let's offset it. I'm just thinking about what kind of aesthetics I want. Yeah, let's extrude it out, and solid no in this case. So this would look like that. That's kind of okay. But what if we, instead of extruding, what if we just select this curve here, make a copy of it, and just copy it to here, like that, and take this curve here. Let me turn off the GUNPLA model. So we have three curves now, and I'll just take the large one and move it by like 1.6 millimeters here, something like that. And then I loft between these two, loft between these two, extrude curve, solid no, and extrude it a bit here, so it looks like that. I don't like how it looks. It doesn't look good. What about like that? That's a bit better. If we round it off, that's okay, but I also don't really enjoy that. Let me just extrude curve, do something like this. How far does it stretch out? That's a bit far. That is a bit far. But we can fix that, that's fine. So I will actually just select everything, join, cap, solid points on, select these three control points and move them back by like 3 millimeters or something like that. Yeah, that's a bit better. I'm just wondering if it won't intersect. Just in case, I will move it back even more. 2 more millimeters or 3 more millimeters. Something like that. Okay. So we have this going on, and then I will repeat the same procedure for this curve here, so or this pipe here. So offset 1.2, move 1.2 or 1.6, it was 1.6, and extrude. I need to measure distance, how much it extrudes. We extruded 7.85, so extrude curve 7.855 curve. Let's just loft between here and here. Super. Join cap cell CRV, delete, cell PT, delete. Okay, we have this cleaned up. So now we need to make it nice. What if this gets filleted? Fillet edge, radius 0.5. Radius 1. I don't know. What about here? Yeah, this is fine. Okay, we can use that, but not 1, rather smaller, 0.5. When it comes down to aesthetics, it's always, this kind of work, just trying out different things and seeing what kind of sticks and what doesn't. So I wanted this to be, I think we're getting closer for this being something like a cannon. So I will make it into a cannon, 0.8, something like that. Planar surface, extrude curve. This one goes in by 1.2 or 1.5. Cap, oh, sorry, not cap, join, and then cap. There we go. Let's see how it looks like with emap on. And that's not bad. Why is it so jagged though? Minimum initial grid quads, let's try 100, preview. Still pretty bad. Simple controls, more polygons, preview. And that's better. Okay, so we have this going on. I like it. Yeah, I like how this looks like. We will of course make it more interesting, but as a base form, this is fine. Do we have a curve there? Yes, we do. We will offset it inwards. Planar surface, delete, extract or extrude curve inwards. Was it 1.5? I believe it was. Join everything, cap. There we go, we have this going on. Time for some chamfers. Chamfer edge, 0.5. That's way too much. 0.3. That's better. Okay. So we have this. It might not even show up in the 3D print, but it's nice to know that we kind of have it, right? So we have that, and we have the model. I enjoy how this is starting to look like. That's looking good. So let me select these two guys, mirror them to 0, like that. Okay. And let's do some cleaning up. So first things first, this guy here, isolate. I will I don't like this edge, this edge of the plate here, so I will chamfer it. Chamfer edge, and rather, should we chamfer this one first? Yeah, we should, and we will use like 1 millimeter for this chamfer here, so that it cuts away like that. And then we will do 0.5 millimeter chamfer edge on all of, oops, not that, but rather that. So I have that going on. It breaks there, huh? Shit. Also breaks there. So that was with 0.5. Okay, let's try 0.3. Still breaks. Do we need to really fillet this, or rather chamfer this? Okay, 0.5 chamfer for this edge here, and then chamfer edge again, here, here, and here. Ah, crap. It does break. Well, it technically does it, but it does it poorly. Can we fillet edge though? 0.5 fillet on this edge. Yeah, fillet seems to be doing a better job. So let's see how it would work with this. That's not that bad. It's not great, but it's not that bad. So when dealing with chamfers and fillets, this is usually like 90% of the work, just trying to figure out what the heck is not working. So okay, fillet edge radius 0 or radius of 1 millimeter for this edge here. Okay, and then fillet edge radius of 0.3 millimeters for here. Oh, that's clean, that's good. Okay, so now I just softened that edge there to just make sure that the fillet works properly. So usually when things don't work out, you need to pre-chamfer a sharp edge to make them kind of work. So now this seems to be okay. Emap on. Yeah, that fillet is fine. That's good. That's good. That's not great, but acceptable. And that's okay as well. Okay. So we have this this portion done here. We don't really need to do anything here. Well, I do want to chamfer that edge, so we use 0.5. And so just so that I don't forget, I will show selected, and I will show this guy, or rather isolate this guy, and also chamfer chamfer edge for this guy as well. And for that, we will need to delete these two. Okay, so we have that done. What about this one? Well, we will definitely want to chamfer this edge here. That's a no-brainer, just so that it's not a very sharp corner. This one is okay. So now I'm just, I'm not detailing it. Don't think that I'm detailing this. I'm just cleaning it up. Fillet edge. So I want to fillet this one. More. 0.5. Basically, you don't want to have any these kind of very sharp edges when dealing with 3D printing. So I'm going through all of the geometry one by one, and making sure that every edge is either filleted or chamfered and I don't have very sharp, very sharp edges anywhere. So here everything is kind of okay except this edge, except this edge here. So I will chamfer edge, chamfer this guy. Now it's fine. That's good. Show selected. What else do we have here? All right, so this one needs to be gone. Then we have these guys here, and I believe I've fixed all of them, and this one is done, and this one is done. Okay, so we're getting close to the end of this particular tutorial, because I've already set up the connection to the robot. The last thing that I'm going to do though is I'm going to make this isolate. I'm going to make this guy 3D printable, because right now as it is, there's no way to make this, you know, to make this print. So what I'm thinking of doing is I'm thinking of cutting it in half right through the middle. So cutting it in half and then somehow saving this eyeball here. So how do we do this? So first of all, I need to extract. Let's do extract surface. I will extract this, which means that the sphere and the, I'll call this the eyeball. And the sphere and the eyeball get disconnected like that. And I will actually move or copy this eyeball along the x-axis by 20, like that. And let me actually delete it. I should have moved it. Okay, so we have this going on. Now I need to I need to fill this in, and basically this eyeball guy here needs to be a separate geometry, right? So first of all, it doesn't have any thickness. I need to give it thickness. I will extract not extract, duplicate edge. I'll get that ring there, and I'll extrude curve, and I'll extrude it by 3.5. Let's do 3.5 millimeters, like that. And I'll actually take that cylinder here, and I'll move it back by -20, or copy it back by -20, so that I have a copy on it in the correct position. And now let's first clean this up. So I will join these guys up and type in cap, and now this is a kind of clean form. And as with everything, I will chamfer the edge of this form here in the back so that it fits better into the slot. And now we need to make the slot. So we have this extrusion here. Let me isolate it. So we have this extrusion which we will duplicate edge of. So we have these two edges, and I will offset both of those edges by 0.1 millimeters outwards, like that, to give it a little bit of a tolerance. I will loft these two edges together. I will cap to make it into a closed I'll get there, into a closed polysurface. And I will, just like we did the chamfer with the eye itself, I will do the chamfer here. So chamfer edge, just like that. Okay, So now we can show selected like that, and we can Boolean difference out the cylinder from our shape. Okay, so we have that going on. Show selected again, show the eye, and move it back by -20 into the slot. Let me create a clipping plane just to make, I always like to make sure, like double, triple sure that everything fits, and it seems to be fitting quite well. Okay, so we have this guy separated, and now I can cut, isolate, I can cut the shape into 2 halves. So I will just create a box from 0, and I'll just make it pretty damn big, so to make sure that, you know, kind of it intersects with half of the sphere. And since this is a symmetric model, right, the box, since it's created at 0, 0, 0 coordinates, is going to be right in the middle, running through the middle of this form. And I will use Boolean difference. Yeah, I will use, Boolean split. I will use Boolean split. Select surfaces to split. I will split this guy, enter. Select cutting surfaces, this box, enter. And then I can just delete this box. And now I have 2 halves of it. So if I move it away, you can see how this whole thing comes together. Okay, let me show. We have everything here set up. Oh, so this one can be printed in place with the sphere. Should we do it? Should we use Boolean union on it? We'll decide later. So now we have that. I'm just making sure that we don't have anything left. So for the next video, I'm going to actually start 3D printing, and I'll take these forms and I will kind of rotate them in you know, in correct orientation to be 3D printable. And I will just print a really quick draft model to make sure that everything sits nicely. And we'll start the next video with that. Right. So let me spend a little bit of time preparing this. And the next video is going to be in a few days. So hang around until then and check it out. And subscribe so that you don't miss it. Bye!